How about the reflection of 3 and negative 4 about the line representing the angle 30 degrees? Take note that 3 and negative 4 is actually in the fourth quadrant. It's actually found here, assuming that all grids are 1, the negative 4 somewhere here. This is our point 3 and negative 4. And we are going to find its reflection along the line representing the 30 degrees. I might not be able to provide you with a better form of a line representing 30 degrees, but let me try to use this one here. Assuming this is 30 degrees, okay? So say for example, this is 30 degrees as your theta. If assuming that is correct, we're going to reflect this point somewhere in that direction, and the reflection might come out on the second quadrant. Let's try to verify later on if our answer is really on the second quadrant, because we do have a formula for this. The reflection of your point X along the line represented by your angle is given as the product of two matrices. You have here the cosine twice theta, sine twice theta, sine twice theta, negative cosine twice theta, times the component of your x, x sub 1 and x sub 2. The product of this is actually defined because you have a 2 by 2 matrix times 2 by 1 matrix. The result is another 2 by 1 matrix which can be interpreted into another point. So let us continue this. Take note that our x is actually 3 and negative 4, and our angle is 30 degrees. Let's find out if the reflection is really on the second quadrant. So we have here the reflection of x along the line represented by the angle. This is actually, so again, let me place it at the bottom. Cosine of your twice 30 degrees, sine twice 30 degrees, sine twice 30 degrees, negative cosine twice 30 degrees, times the components of your x, 3 and negative 4. Let's start by simplifying the trigonometric ratios. You have your cosine 60 degrees, sine 60 degrees, sine 60 degrees minus cosine 60 degrees, 3, negative 4. Cosine 60 is actually, if you're correct, if I'm correct, it's 1/2, right? Cosine 60 is somewhere here. So in the unit circle, it's actually 1/2. Sine 60 is square root of 3 over 2. So similar here. And negative of 1/2, which is negative 1/2. 3 and negative 4. Okay? So we'll have here 1/2, square root of 3 over 2, square root of 3 over 2, negative 1/2 times 3 and negative 4. Take note of multiplying matrices. So again, this is the reflection of x along the line representing the angle. So this is actually a 2 by 1 matrix. You have here 1/2 times 3 plus square root of 3 over 2 times negative 4. Okay? And then square root of 3 over 2 times 3 plus negative 1/2 times negative 4, which will give us a result 3/2 plus, take note of this, this one here, so negative 2. So you'll have here minus, allow me to erase this one here, that's negative 2, let me use the same color, minus 2 square root of 3. The other one is 3 square root of 3 over 2. Then of course you have that positive 2, so plus 2. This is the point reflection of our point 3 and negative 4 along the angle of the line represented by the angle 30 degrees. So 3/2 minus 2 square root of 3 and 3 square root of 3 over 2 plus 2. To verify this to be correct or not, let's try to take its approximate value. So we can actually plot this on our Cartesian plane. 3/2 minus 2 square root of 3. So it's approximately negative 1.96. And for 3 square root of 3, divide by 2 plus 2, you will have approximately 4.6. That's just an approximation. So negative 1.96 is somewhere here. So it's almost 2. So basically my graph earlier, this one is incorrect. I mean my plot. Okay? And then 4.6. So 4.6 is somewhere here. 1, 2, 3, 4. So almost half. It's somewhere here. Yeah. I guess my 30-degree I mean the graph or the line representing 30 degrees is more or less close to the real value, because I could see that this point here is more or less halfway to that segment passing through the foot of perpendicularity. This it's its reflection along 30-degree angle. Okay, this is how we solve the reflection of a point along a certain angle. This will open up understanding on rotation later on. We'll be talking about rotation right after this, because on rotation we are going to have an angle as well in a certain point to be rotated in a certain angle. But this time, on that rotation concept, we will no longer have a line for to be reflection, right line needed for a reflection, because we're simply going to rotate a certain point using an angle. Thank you very much for watching.